Hey, Math 8 people. Guess what? For today's notes, we have a guest appearance. Say hi to Mrs. Smith.
Hey, everybody. It's a fun day of section 3.10 on your notes. Yeah. Today, wait, is this the right group?
It is.
Okay. Today, you're going to learn multiple methods for solving one variable equation, allowing you to solve more complicated equations that you may not have seen before. Embrace the Hall world that you get to live in. He's the best there is. Happy mathing.
All right. She has introduced it. We'll get started. This first part will go quick. Make sure you stay around for the examples at the end. They are the most important. All right. So there are actually 3 different ways to solve an equation, and we're going to know them by name. You will need their names on your homework. The first one is called solving by rewriting. Bam. Bam. There we go. Solve by rewriting. This is where you solve the equation by first. That's right. Rewriting the equation in a simpler form. It is generally the way most students would start a more complicated equation. So you can see here I have an example. And the way most people would probably start this problem is they would do this. They would rewrite the left side by distributing the 4. So I would distribute the 4. I would get 4x plus 12 equals 20. And I have rewritten the problem in a simpler form. And then I would solve it. I'm not actually going to solve it. But this is what I would do first. And whatever you do first dictates what method you're using. So when you simplify the problem first by rewriting it, that is known as rewriting. The next method is called undoing. Now, this is the way most students learn to solve the most basic problems. This is where you solve an equation by first doing something on both sides that begins to get the x by itself, right? You undo one of the operations to eliminate one of the numbers. And for each number you want to eliminate to get the variable by itself, you have to undo its operation. So undoing is when we get rid of a number by doing the opposite, or as I said here, the inverse operation. And this is how most students first learn to solve equations. Remember back when you had x plus 3 equals 10, and you solve that by undoing the adding 3. So let's look at how we would do this in this example. So instead of distributing first, let's eliminate the 4 by undoing its operation. This is actually a good way to do this problem. Instead of distributing the 4, let's just get rid of the 4 by dividing both sides by 4. That leaves me with x plus 3 equals 5. Wasn't that easy? That, I think, is actually easier than doing it this way first. Distributing the 4. I think getting rid of the 4 was easier. And that's kind of our goal today, to give you some thoughts on ways that might make your equation solving quicker and more efficient if you understand them. All right, so undoing is what this is called, undoing, and that is when you undo an operation on both sides of the problem first, right? It's always what you do first. All right, and the last one is called looking inside. Looking inside is where you solve the equation by first looking inside at a group, and you're going to pull out that group and write a simpler equation. So I want to use the same example here, and this is the deal. You know, most people would know that 4 times 5 is how you get 20. So I could actually look inside this problem And I could say this x plus 3, I know it's got to be 5 because 4 times 5 is 20. So I could pull out the x plus 3 and say x plus 3 has to equal 5 because I know 4 times 5 is 20. And then I would finish solving it. So again, here's a little note. Think about everything inside the parentheses as a group. After all, the parentheses group stuff together. The contents of those parentheses must be 5 if 4 times that group equals 20. So I pulled out this group and set it equal to 5. You know, another example is what we've been doing. This maybe is a better example of this. If you had 2 to the 4x, and that equaled 2 to the x plus 3, right? This is one you would solve by looking inside. You'd forget about the 2's and you would look at just this and this, and you'd say, all right, those guys must be equal to each other because the base is the same. This is another example of looking inside the problem and finding something simpler to solve. All right, those are our 3 methods: looking inside, undoing, and rewriting. Now I have this example on the back where I have described 3 problems and what I did to solve them, and you're supposed to match them up with each name. See if you can do that before I do it. Pause for me, and then come back and see if you get what I got. Okay, what you should have gotten was this. Letter A is where we looked at the 8x and the 24, and we said 8x must equal 24. That is looking inside. That's kind of the example I just gave, so that would be A. In this problem, it looks like I'm going to subtract 4 from both sides, so I'm getting rid of a number by undoing its operation. That would be undoing. This must be B. And so C must be rewriting, and it is. I'm taking 4 times 2x minus 3, and I'm rewriting it as 8x minus 12. So that is C. Did you get them? All right. The last thing I want to cover here is I want to cover the examples that I think are difficult examples. I think they will be good for you to look at. And here they are. I'm going to do all of these by rewriting to make them simpler. And that's what I think you probably could use some practice at. But before I do this, I got to show you something. I got to show you this. So we are now going to look at equations that have both an x squared and an x in them. This is an equation that you have probably not solved before. How do you solve an equation that has both an x squared in it and an x in it? That is very difficult to do. And at this point, you probably do not know how to do it. And we're not going to learn how to do it in this class. I wish we were doing this discussion in class because this is really a good class discussion to talk about. Not so good on video. But you're going to have to take my word for it. There is no good way to get the x by itself when there is both an x squared and an x in the problem. Maybe next time you're in class, we'll talk about why. But there's really not a good way to do it. There are many ways. You could use the quadratic formula. That'd be one way. There is a way called factoring. You might use synthetic division, that's an N, synthetic division, but all of these are skills you will learn in a future class. There is no easy way to get the x by itself at the moment. So we are going to be looking at problems that are going to have both an x squared and an x in them, but they're going to be easy, you will see. So here we go. The first thing I'm going to want to do to solve this is it's telling me solve them by rewriting. And this is something we practiced a couple sections ago, how to multiply these polynomials together. So the first thing I'm going to want to do is multiply this times this. So that would be x times each thing. That'd be 5x squared, and that would be plus 6x. Then negative 1 times that would be negative 5x. Negative 1 times that would be negative 6. And when I combine my like terms, I get this. Now, the other side does not need rewritten, so I can just bring it down. But all of this is rewriting, right? And now that I have simplified it by rewriting, I can start undoing stuff. And here's why these problems, even though they have both an x squared and an x, here's why they're relatively easy, is because the x squared is the same on both sides. So I can subtract 5x squared from both sides, and I will no longer have an x squared. On this side, I will have 43, and over here, I will have x minus 6. And now that's easy to solve, right? Add 6 to both sides. Okay, so the tricky part here was rewriting it and getting rid of the x squared, which wasn't that tricky because it's the same on both sides. Let's look at this next example. This has a trick in it also. In this example, again, I need to rewrite both sides. Now, this side is especially tricky to rewrite. A lot of students think that when you take this exponent, you just make it x squared plus 9. But that is not true. That only works when you have a product in parentheses. We don't have a product. We have stuff added together in parentheses. Think about what that exponent 2 actually means. That exponent 2 actually means to multiply this thing times itself. This is really x plus 3 times x plus 3. And we're going to need to do the same thing we did over here. We're going to need to distribute it. I'm going to need to do x times x plus x times 3. That's that one. And then 3 times x plus 3 times 3. And then I will combine my like terms, and I will get x squared plus 6x plus 9. All right. On the other side, I need to distribute the negative 3, which gives me x squared minus 3 plus 3x. I could just bring that down. X squared minus 3 plus 3x. So all of this is just rewriting to make it simpler. All right, now again, I have both an x squared and an x in this problem. But fortunately, the x squared is the same on both sides, so I can eliminate it completely by subtracting, I don't like when that happens, by subtracting x squared on both sides. And that gives me 6x plus 9 equals negative 3 plus 2x. And now you're home free, right? I don't need to finish solving this. You know how to solve it from there. The tricky part was rewriting it and getting rid of the x squared. All right, I have one more example, and this is really tricky, I think. So again, I need to rewrite both sides to make them simpler. The left side should be relatively easy. You're just going to distribute the negative 2 and get 4x squared minus 2x plus 10. It's the right side that is tricky. So if I'm going to simplify that right side, the first thing I would probably do is I'd go inside the parentheses and I'd reduce the 8 over 4. I would make 8 over 4 be 2x over 1y, or just y. And then I would probably apply the exponent to each thing in the parenthesis. And if I apply that exponent to each thing, I get 4x squared over y squared, right? Apply that to each thing. And I'd probably take this and flip it, because it's a negative exponent, means to flip it. So that would actually be y squared over 1, or just y squared. And now I can do one more thing. I can cancel out the y squareds. I have a y squared on top and a y squared on the bottom. So really this thing is just 4x squared over 1, or 4x squared. Look how that's simplified down quite nicely. And so I have 4x squared minus 2x plus 10 equals 4x squared. One last thing to help you here. Now I would probably get rid of the 4x squared on both sides. Again, every problem we do that has an x squared and an x, we will be able to cancel out the x squared. And that gives me negative 2x plus 10 equals 0. And now I could solve it, right? Subtract 10, divide by negative 2. I guess you get x equals 5. All right, those are some difficult examples. I hope they help. Good luck on the homework.